Athletes, here we are looking at the measures of center of data. In this course, we're going to say that the measures of center of data are two things. One, our mean, and the second one, our median. So first off, our mean. How do we calculate our mean? Well, that is the sum of all of the data values divided by the number of data values. Often this is given the variable of n. Okay. Note that the mean is also known as your average of a set of data. Okay, so let's look at an example here. So if we're given that 12 people show a series of television commercials, and we're asked to write down the commercials that they remember. The data below shows how many commercials each person remembered. So if I want to find the mean, okay, I'm going to find the average. So first thing I'm going to do is I need to add all of these up. So 7 plus 10 plus 12 plus 10 again plus 8 plus 13 plus 10 plus 6 plus 5 plus 11 plus 6 plus 10, and that is equal to 108. Okay. So then I take 108, I divide it by my n. Well, n is the number of sets of data, so I have 12, so I have 108 divided by 12, and that equals 9. So it's 9 commercials was the mean for people remembering. Okay, let's look at another example here. So this example, we're using a frequency table. So the thing we have to understand with the frequency table, this is the number of aces during a tennis tournament. So we can see, all right, there was one ace that happened 4 times. 2 aces happened 11 times. 3 aces happened 18 times. So this is discrete data here. So with this frequency table, we got to understand that 2 aces happened 11 times. So in order to know how many aces that were, we have to do the products. Okay, so oftentimes it's nice to just add another row or column to your set of data and find the products of your aces times your frequency. So, well, 1 happened 4 times, there's representing 4 total aces. Well, 2 aces that happened 11 times is representing 22. So I'm just taking the product of these two numbers. 3 aces happening 18 times is going to be 54 as the product. 4 and 13 is going to be 52. 5 and 3 is 35. And 6 and 2 is representing 12 aces. Okay, so to determine the mean, I have to add all these numbers up. Okay, so 4 plus 22 plus 54 plus 52 plus 35 plus 12 is equal to 179. Well, how many total serves did I observe? Well, to understand the number of points in my data set, okay, I'm going to have to add up all of these numbers. Right? How many times did it happen? Okay, so n is equal to 4 plus 11 plus 18 plus 13 plus 7 plus 2, which ends up being 55 serves we observed. So 179 divided by 55, or I should say tournaments. Okay, and what we end up getting is approximately 3.25 aces that we witnessed being served there. Okay, so big notes, remember with your finding your mean with your frequency table, try and make a product bar so that you get all of the values added together, and then finding your n. Okay. So our next example here, we're going to be talking about the median. The median is the middle value of an ordered set. So the important thing is we're always going to have to order our data in order to find the middle value in our data set. Okay, so if it's an odd number, it's fairly straightforward. If we have an odd number in our data set, let's say 23. So then what I can do is I use this equation and I can say 23 plus 1 is 24 divided by 2 is 12. So that tells me that the 12th ordered value is the median. We can think that with 23 we're going to have 11 data points here, our 12th one, right? And then we're going to have 11 different values over to the right side. So this 12th value is the one in the middle when we have 23. Okay, so that's even when it's odd. But when it's even, okay, the median is going to be the average of two values. So if you did this equation, 28 is our n. So we do 28 plus 1 is 29 divided by 2 is 14.5. So that means we have to take the average of the 14th and 15th. So if we're thinking about 28 sets of data, we have 14 pieces of data here, and we have 14 pieces of data here. So there is no middle. So what we end up doing is taking the last number in this set, which would be the 14th one, and the first one in this set, in this being the 15th, and then finding the average of these. Okay, so let's look at how this is going to work out. So in the first thing that we always want to do is we want to order the set of data. So for A, if I put these in order, okay, I'm going to get a 3. I always like to go through and cross them off. And then my next biggest is a 4. And then I have 2 5s. Okay. Then it looks like I have 1, 2, 3, 4 6s. 4 6s. Okay. I also have 4 7s, so 1, 2, 3, 4. 4 7s. Okay. I have 2 8s. No 9s, but I have a 10. Okay. So if I look here, I have 15 is my n. I have 15 data sets. So because it's odd, okay, I know if I do 15 plus 1 divided by 2, that's 16 divided by 2, that's 8. So my 8th term, so if I count this over, 1, 2, 3, 4, 5, 6, 7, 8th, this term is the one in the middle. I have 7 terms here, and I have 7 terms here. So 6 is equal to the median. Okay, this is part A. Okay, so this would be peas in a pod. Okay, so another set of data. Okay, did this experiment again, and we get these. Okay, so again, I have to order them. So I get a 3. I get 1 4. I get 2 5s. I have 4 6s. 1, 2, 3, 4. Okay, I have 4 7s. 1, 2, 3, 4. I have 2 8s. I have a 9, and I have a 10. I like crossing them out because now I know I have accounted for them all. So I can see that now, because I have an additional value, my 16 is equal to n. Okay, so I do 16 plus 1 divided by 2, well, that's 17. That's 8.5. So I have to take the average of the 8th and the 9th value. Okay, so as I go over the 8th value, so this is 1, 2, 3, 4, 5, 6, 7, 8. So that means this is the middle. I should have 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then these two values here, I find the average. So 6 plus 7 divided by 2 is 13 divided by 2, which is equal to 6.5. And that is my median for that data set in part B. Okay, so a little bit different if we have an even amount of data or odd amount of data. Okay, so let's look at our next example here. Okay, so now same thing as with our median. Okay, with our mean, we want to be able to find our median in a frequency table. Well, this one's a little bit easier. We don't have to find our products, but we still have to understand. First, we got to figure out our n. So how many total, so in this we're talking about, shows the number of people at each table at a restaurant. Okay, so we want to know how many tables were actually observed. Okay, so n, so we have 1, 3, 9, 12, 7, 4, and 2. So we can see that there is 38 tables at this restaurant. Okay, so because it's even, and if I do 38 plus 1 divided by 2, that's equal to 39 divided by 2, which is equal to 19, which is equal to 19.5. Okay, so I want to know the 19th and the 20th piece of data to find the ones in the middle. What's nice is these are already ordered. Okay, so I can see here this is representing 1, 3, so there's the first 4, and this represents the first 13 sets of data. So there's a lot of tables with 9 in there. So if I'm thinking about the first 13 pieces of data, I know that the next 12 numbers are going to be 9s. Okay, so that means 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I know that the 19th, so 13, 14, 15, 16, 17, 18, 19, 19th is a 9, the 20th is a 9, and to find the average of 2 9s, well, that's going to be equal to 9. So that is our median of our set of data. So that's how we find a median with a frequency table. Okay, so sometimes we need to find the mean of 6 figures. So in this example, we know the mean. Okay, so we have 17.5. What is the sum of all these scores? Well, this is involving 6 scores. So going backwards, I know that 78.5 is equal to the mean, which that was equal to the sum divided by 6. Well, to find what the sum is, I'm going to undo this equation, multiply that side by 6, multiply this side by 6, and we can see that the sum for 71 is equal to our sum. Okay, so we can use our equations and problem solve if we're maybe given the mean, and we can work backwards. Okay, so here we know that the mean is 8 of this data set, and we need to find x. So we know that 10 plus 7 plus 3 plus 6 plus x divided by how many pieces of data do we have? Well, we have 1, 2, 3, 4, 5. that mean is 8. So to undo this, I'm going to first undo this division dividing by 5. So I multiply it by 5 on both sides. Okay, so these cancel out. And then I'm going to add these up. So I got 10 plus 7 is 17. 3 is 20. And so I got 26 plus x is equal to 8 times 5, which is 40. Okay, so then I have to find that to get x by itself, I subtract 26, subtract 26. So I get x is equal to 14, would be the value at which would make the mean of this data set 8. Okay. Last example here, we're trying to estimate the mean of grouped data. So sometimes, and when we have continuous data, we would have a frequency chart that is grouped here. So notice that they're on intervals from 40 to 50, 50 to 60, 60 to 70. So if I'm asked to find the mean of this data set, I can't really, of these three numbers that are in between 50 and 60, I don't necessarily know if it's 51, 52, 53, or they could be 53, 58, 59. So what I want to do is I'm going to estimate the mean by using the interval midpoint. So instead of using the highest or lowest number, I'm just going to use the middle number and assume all those numbers in that interval are that interval midpoint. Okay, so the midpoint of 40 and 45, okay, or 40 and 50 is 45. Okay, the midpoint between 50 and 60 is 55, 65. So recognizing the pattern can definitely help us here. 85, 95, and 105. Okay, so now that we have that midpoint, we do the same thing as we did before, and we do our frequency times that value. So we know that with these 17 numbers, most likely they're not all 65, but we're going to use that number to estimate this here. So as I take my products here, okay, I do 1 times 45, and I get 45. 3 times 55 is 165. 65 times 17 is 1,105. 75 times 39 is 2,925. 85 times 48 is 4,080. 95 times 17 is 1,615. And 105 times 4 is 420. If I add those up and I find the total of all those products, I get 10,355. Okay, so that is my total. If I added up all those 129 cars' speeds. Okay, so I do 10,335. Okay, divided by how many cars that I observed, and that was 129. And I'm going to get an approximate average speed here of about 80.3. And again, if I can think about my units, I'm kilometers per hour. Okay, so that's how you estimate a mean from group data here if you're dealing with continuous data in a frequency table. That concludes our notes tonight. Please highlight any questions you might have and bring